In 2025, voice agents have taken off and are supposed to be have a huge impact on in enabling seamless human computer interaction at scale. This is across many business verticals, customer service, healthcare, gaming, and so on. And there's several no-code platforms like VAPI or Retell and low-level frameworks that give you more control like Pipecat or LiveKit and so on. And so all of these are enabling designing complex voice agents. However, if you take stock of the market and probably go to conferences like Vapicon and check if the voice demos actually transfer to production or just work seamlessly if you repeat them a few times, uh, the case is that they fail more often that they succeed. There are several reasons to that, and in this video, I'm going to discuss the key blockers that the voice agents or voice apps face in 2025. So the top blocker is STT or the STT model, the real-time transcription. Uh, since the since the Whisper model from OpenAI was introduced with remarkable STT accuracy, which was far beyond anything that existed before that, the models STT models give you pretty good performance, pretty good accuracy, but in practice for business cases they may not be good enough. So for example, they are still not good enough with emails, addresses, with alphanumeric uh, words. These are problems that humans also face, and the models have not improved, especially if these words are unique to a particular domain. Accents accents are always a problem, and while these models are pretty good, several accents there are several business cases in which uh, these models fail to detect accents, also punctuation and intonation. So what happens is that if the STT model, which is at the beginning of the pipeline, if that fails, then the error propagates, cascades to all the other components, and the overall agent just fails or stutters. So what we need is a sort of, in spite of these models being pretty good, what we need additionally is some understanding of the context of the conversation, some native understanding, and also a holistic speech understanding. So by holistic, I mean understanding sarcasm, excitement, emotions, and context aware about the domain. These the the current models are do not incorporate emotion seamlessly, do not understand emotion seamlessly, and as well as they need to be fine-tuned for the context. The other thing that they suffer with is long multi-turn conversations. So even text agents suffer with this problem, maintaining the context, excavating the relevant piece of the context uh, relevant to the current conversation point, and this is true for speech agents also. So, for example, turn detection is another issue that the models fail to detect turn correctly or within a small duration that leads to uh, too bad latency. That leads to latency being the model not being that leads to the model being perceived as too sluggish. So you also need careful context management for to enable these multi-turn conversations. Speech models aren't natively good at it. That's one of the big blockers in moving from these demos, POC demos, to the real production environments. The next issue that these models face right now is handling multilinguality. So practical business conversations, for example, customer service, are often mixed language. There's code switching from one language to another in between the conversation. And what we need is the model to understand both the languages seamlessly, transfer information or entities from one language to another. And the current multilingual language support only a small set of languages uh, with high accuracy. and huge. To make these models work truly in the wild, we need to support many more languages. For example, in the Indian context and the Indian subcontinent context. The domain specific accuracy is, like I mentioned, is a problem, continues to be a problem. The models do not know the special terms, they need to be fine tuned, or the special terms relevant to the domain need to be provided as a prompt uh, with variable accuracy even after you provide them as a prompt. So these specialized use cases need more effort. We're moving towards speech to speech models. So there are basically two kinds of models in the market. The traditional cascading, where you have an STT, speech to text, LLM, and then a TTS, text to speech. So speech comes in, audio comes in, converts text, the LLM processes it, generates a response, and then TTS model uh, presents the response to the user, speaks back to the user. These models give you more control, uh, but unfortunately, uh, if there's error in the STT phase, that cascades to the next phases and it makes it very difficult uh, to to manage those errors after that point. The alternative are these speech-to-speech models, real-time models, Gemini Live, OpenAI Real-Time, and then several others which are coming with improvements on a regular basis. These models give you end-to-end speech. You don't need to worry about, for example, turn detection or understanding emotions separately, or have separate detectors for emotion. All of that is handled under the hood in the neural pathways. But the drawback there is that you have less control over the flow. Tool calls are supported to variable extents, and they lose context. They lose the conversation context quite easily right now. So these uh, so both sides have their own disadvantages, the cascading or the speech to speech, and it remains to see which models will, if one of these uh, will be the winner in the game, or both of them will coexist with their own advantages. So yeah, but we definitely need, if you, for the usual normal cases, fused audio plus LLM models are uh, just not the whole cascade, but part of the cascade fused together, and those models are also quite useful in practical context. Finally, well, not finally, these models work in with a single speaker, quiet background environments. To a certain extent, they do support background noise or speakers, but more often than not, they fail when there's a like busy workplace, and they fail to detect the target speaker and the voice, and multiple speakers switching between them. And so natural noisy environments is another step that these models need to take. And the final issue, and this is probably the biggest uh, hurdle that will remain for a long time, even if the other issues get solved, is that we are simultaneously solving for three hard goals. Latency, you want the model to respond quickly. Accuracy, you want the model to respond correctly with the right data, right facts, and have the right tool calls. And the cost of doing all of this should be low. So um, putting them together, it's an extremely hard problem. There's a lot of research, a lot of models being shipped with lower latency, better accuracy, and that's where, uh, but, but keeping the cost low, while generally these models are bigger, and that increases the cost. And so the trade-offs, the big trade-offs right now to make them work in production. So that's a quick overview of the state of voice models, voice AI agents in 2025. I think the biggest issue is STT. Uh, the STT models do not work seamlessly in domain-specific businesses, and that leads to cascading errors, making the user lose belief in agents. reliability of the agents. And if this gets solved, I think the other issues are less are of less significance than this. But this continues to be a really hard problem.